Hello friends, in our previous lecture we have discussed about the optical properties of colloids like Tyndall effect and scattering of light. You can check it in my previous videos. Today we will discuss about the kinetic properties of colloids. But at first one should know the meaning of kinetics. So what is kinetics? Kinetics means motion. So the motion related properties will be discussed here. Basically, it includes various properties that relate to the motion of particles with respect to dispersion medium. The motion is induced by various factors. It can be either thermally induced like Brownian movement, diffusion, osmosis. It can be gravitationally induced like sedimentation, or it can be applied externally such as viscosity. So first one is Brownian motion. What is Brownian motion? It is the random zigzag movement of colloidal particles which may be observed with particles as large as about 5 micrometer. It was explained as resulting from the bombardment of the particles by the molecules of the dispersion medium, as you can see in this clip. The motion of the molecules cannot be observed, of course, because the molecules or particles are too small to see. The motion is affected by two factors, particle size and viscosity. Particle size, which is directly proportional to the velocity, that is, the velocity of the particles increases with decreasing particle size, and viscosity, which is inversely proportional to the velocity. Thus, increasing the viscosity of the medium, which may be accomplished by addition of glycerine or a similar agent, decreases and finally stops the Brownian motion. But it remains unaffected by the nature of colloid which is involved. Now, let's discuss what's the cause behind the motion is. What actually happened is, when a particle is present in a dispersion medium, it experiences force from all directions. When all these forces are equal, they cancel each other and no movement will take place. But on the other side, when the particles experience force from all directions, force from any one direction will dominate and all other forces got neglected, and the particles move in the opposite direction of the dominant force. That is, dominant force push the particle in opposite direction. As you can see in this clip, when a particle of dispersed phase got hit by the particles of dispersion medium from various directions, the dominant force pushes it in the opposite direction. Next is diffusion. Particles diffuse spontaneously from a region of higher concentration to one of lower concentration, which is a direct result of Brownian motion. This process continues until the concentration of the system is uniform throughout. The factors which affect the diffusion rate are best described by Fick's first law. Fick's first law is written as, according to which the amount dq of substance diffusing in time dt across a plane of area S is directly proportional to the change of concentration, that is dc, with distance travelled, that is dx. D is the diffusion coefficient, the amount of material diffusing per unit time across a unit area when dc over dx, called the concentration gradient, is unity, that is 1. It got affected by various factors, among which 3 are here. First, particle size, second, temperature, and third, viscosity of the medium. Particle size and temperature are directly proportional to the velocity of the molecules, while viscosity of the medium is inversely proportional to the velocity of the molecules. And next kinetic property of colloid is sedimentation. It is the process of settling of particles with time under the influence of gravity, as all the particles present in dispersion are either smaller in size or larger in size with respect to each other. As smaller particles are lighter in weight, they experience low force of gravity and high Brownian motion, due to which they require more time to sediment, while those particles which are larger in respect to others are heavier in weight and experience high impact of gravity. On the other side, due to heavy weight, they also have less Brownian motion, due to which particles settle down in lesser time. Now comes the last kinetic property of colloids, that is viscosity. Viscosity is the resistance to flow of particles under stress conditions. When force is applied on a particle, it can either move fast or slow depending on the resistance experienced by it. So from this, it can be concluded that when viscosity decreases, the resistance becomes low and less force is required to move the particle. Similarly, when viscosity increases, resistance also increases and it requires increased force to move. So this is all about the kinetic properties of colloids. Thank you.